Alright everyone, so in this section we're going to be talking about rational functions, particularly how to graph them, but we need to talk about some other particulars about rational functions before we start talking about graphs. First of all, we define a rational function as a function that is a fraction of two polynomials. So if p of x and q of x are polynomials and q of x is not equal to 0, then we can define the function f of x as p divided by q, and we call this a rational function. This is just a fraction of polynomials. So here we have some rational functions, and then their factored forms, and then their domains. Right? Notice that this does not exist when x equals 0. This wouldn't exist with these values of x. And this domain is all real numbers or minus infinity to infinity. So it's important when we talk about rational functions to talk about some notation that we'll use. When we use a little arrow, this just means approaches. And so this is x approaches whatever number c is. The plus means from the right. So that means from bigger values of x. This would tell us x approaches c from the left, so it's approaching from smaller values of x. And then this would just imply x approaches infinity, or x approaches negative infinity. So here is an example with 1 over x. Now as x approaches 0 from the right, y approaches positive infinity. As you approach 0 from the left, it approaches negative infinity. As x approaches infinity, y goes to 0. And as x approaches negative infinity, y approaches 0. So what we have here is just a way to talk about rational functions and the values that they approach, even when the function itself is undefined at those values. So if we want to look at the behavior of this function 1 over x squared, as it approaches some values, well, as x approaches negative infinity, so here's x. As we go to negative infinity, f of x, the function, goes to 0. As x approaches 0 from the left, well, then the function value goes to positive infinity. As we approach 0 from the right, same thing. And then as x approaches positive infinity, the function goes to 0. We can do the same thing here with this example. As x approaches negative infinity, all the way out here, this function is going to approach 0. As you approach 2 from the left, this thing is going down, so it's going to give us negative infinity. As we approach 2 from the right, positive infinity. And then as x goes to infinity, the function goes to 0.